Hello dear students, welcome to Gurudev PU Science College, Dharwad. I am Mr. Nagaraj Durgannavar, Physics Lecturer, Department of Physics. Today I am in front of you to discuss the model question paper given for the SSLC students. So Karnataka SSLC annual examination model question paper 2, in that I am discussing only a part of physics. So first we will discuss MCQs. The first MCQ is nothing but multiple choice questions. The question is like this: one of the properties of concave lens. What is the property of a concave lens? So here four options are there. It is thinner at the edges and thicker at the middle, diverges the light, forms real and inverted image, and converges the light rays, which is a property suitable for this question. So first, for the answer, we will take this diagram which is there in your textbook. So this is convex lens which converges, but here they have given concave lens, so this option wrong. And this forms real and inverted image, but concave lens is this one, this is concave. So forms real and inverted image, that is also wrong, because convex lens will form real image and inverted image, inverted image, where second one diverges the light, this is converges, this is the diverging, so this is the right one. And also we'll see the first option, it is thinner at the edges and thicker at the middle, which is this lens, but actually concave lens is thinner at the middle and thicker at the edges. So by these observations you can choose the answer as diverges the light rays. We'll move to the next question. Second one is, the crystalline lens of the eye in old age people sometimes becomes milky and cloudy. This particular diseases we can observe in our elder parents, old age parents, like our grandfather, grandmother, their eye is little bit milky, that is problem is called as cataract. So here the answer is cataract. We'll move to the next question, that is third question. In the Fleming's left hand rule, the middle finger indicates the direction of either it is a current, induced current, movement of the conductor, or magnetic field, right? So I have taken the diagram which is there in your textbook, that is this diagram, and you can see that this is a Fleming's left hand rule. According to this Fleming left hand rule, thumb represents the motion, forefinger represents the direction of field, and central finger represents the direction of current. So here the option is current, because they are asking the middle finger. So this is the middle finger which represents the current. Okay guys, so this is 3 MCQs. Now we'll move towards the 1 mark question. So this is 1 mark question. So if the focal length of a spherical mirror is 25 centimeter, that is focal length, then find its radius of curvature. We need to calculate the radius of curvature, that is R. Now there is a relation between focal length and radius of curvature, that is focal length is equal to half of the radius of curvature. F is equal to R by 2, right? So here focal length is given divided by 2. So you need to calculate R here. From this question, what is R? R is equal to 2F. So we can write 2 into 25, which is 50 centimeter is your answer. Then draw the symbol diagram of two electric cells connected in series in an electric circuit. That is there in your textbook. You can go a series of electrical devices they have given mentioned. In that I have taken a battery or a combination of cells. So this is positive of the cell and this is negative of the second cell. So first battery's negative cell is negative part is connected to positive terminal of the second battery. So this is cell EMF E1 and this is cell EMF E2, which are connected in series. This is for two electric cells connected in series. Next 2 mark question. So in the 2 mark question, how does our eye accommodate to see the objects at different distances? So I have taken the diagram of eye here, which is there in your textbook. So here when we see the far object, what happens to eye? When we see near the object, what happens to the eye? This thing you know that. If you want, you can observe. You keep your left hand first finger like this and another finger like this. And first you observe this finger and later you observe that there is some relaxation in the muscles. That is because of ciliary muscles. This ciliary muscles is very important. So you have to go through these lines. Look at here. The eye lens is composed of fibrous jelly like material. Its curvature can be modified some extent by ciliary muscles. See here. The curvature of the eye lens is alteration by ciliary muscles. The change in the curvature of the eye lens can thus change in its focal length. See, the change in the curvature of the eye lens can thus change in the focal length. When the muscles are relaxed, when the muscles are relaxed, what happens when the muscles are relaxed? The lens becomes thin. The lens becomes thin. Nothing but it's, see, this is a lens. If its muscles are here, there, ciliary muscles, if they are relaxed, then the lens will like this. So the radius of aperture of the lens will increases. So right, thus the focal length increases. So focal length increases, we are enabled to see the distant object, far objects clearly. See, you can say that when the ciliary muscles are relaxed, the curvature of the lens will increase, focal length will increase, and we can see the far objects very clearly. And if you want to observe the near object, then what you have to do? The ciliary muscle will contract. When you are looking objects closer to the eye, ciliary muscles will contract. This increases the curvature of the eye. Hence the eye lens then becomes thicker. Then consequently focal length of the eye decreases. This enables to see the near object clearly. So if you want to do this experiment, you can hold your hand like this and you observe this finger and this finger. So there is a muscles in the eye, that is ciliary muscle will change, that you can experience that, guys. Okay, yes, we'll move to the next question. Stars appear to be twinkling. Why the stars twinkle? Correct. So that is because of refraction of the light. See, you can see here in the picture diagram, this is a star. So we have here lot of different density of the medium. So here as we go far away from earth, so here it is rarer, becomes rarer. As you coming towards the earth surface, it is denser. Now the light is coming from star, which is coming from rarer medium to denser medium. We know that whenever light travel from rarer to denser medium, it will bend towards the normal. So it is bending like this. Now after receiving that light and you are observing again to the star, now this time the light is moving from denser medium to rarer medium. So it moves away from the normal. That is the reason why this star shift here. And the medium is changes from point to point. Therefore multiple times of refraction takes place. So that is the reason this situation or a position of a star may vary. That is observed as a twinkling of star. So that all the things are given here. You can pause and you can note down the answer. This much answer you have to write. Okay, guys? Yes, we will move to the next question. Okay, 7th one. So what is the solenoid and how it can be converted into electromagnet? So here the diagram you can see that the solenoid. So what is solenoid here? A coil of many circular turns, insulated copper wire wrapped closely into the shape of cylinder is called solenoid. So which you can see here. So here the red turns are there, no? These are wires wounded, copper wire wounded, and one end of the copper wire is connected to battery, another end is connected to negative terminal of the battery with key. Whenever this key is closed, when current begins to flow this behaves as a magnet. So this is a solenoid. So then our next question is, how can it be converted into an electromagnet, right? So this is electromagnet. So a strong magnetic field produced inside a solenoid. First what happens? When whenever current flow through this solenoid, a strong magnetic field developed in the solenoid, and this solenoid is this magnetic field is used to magnetize a piece of magnetic material like soft iron. We place here, this is soft iron, then this soft iron become electromagnet. This is how a solenoid can be used as a electromagnet. Next 3 marks question. In 3 marks question, draw the diagram to show recombination of the spectrum of white light. Correct? So here, once a white light incident on a prism, correct, this is called prism, and we know that the light will start scattering or diffracting, and it forms 7 different colors, that is violet, indigo, blue, green, yellow, orange, red, Vibgyor. Then that Vibgyor, 7 different colors, incident on a reversed prism. This is normal prism and this is a reversed prism. Then these rays incident on this surface and they converge and they emit a white light only. This is a diagram for recombination of the spectrum of white light. You have to draw this diagram. Next, dear students, that is 9th question. State Ohm's law. How are ammeter and voltmeter are connected in an electrical circuit, and why are these instruments have to be connected in the circuit? Correct? So first part we will study what is Ohm's law. So in 1827, German physicist known as George Simon Ohm found out relationship between the voltage and current. So the potential difference V across the ends of a given metallic wire, suppose this is a metallic wire and it is connected to a battery. This is a wire of length A and B, correct? So battery has a potential difference V. Whenever current flows through this wire I, that current is directly proportional to the potential difference applied across ends of the wire. Perhaps the temperature must be constant. Temperature must be constant. This is very important. See, that is the statement they have given here. The potential difference V across the ends of given metallic wire in an electric circuit is directly proportional to the current flowing through that wire, provided its temperature must be remain same. So this is called Ohm's law, and here you must write after statement. You no need to write all these things, but from here you have to write, you have to up to here, and then V is directly proportional to I, you have to write. When you remove this proportionality constant, that is constant, which we recall it as resistance R. We call it as resistance R. Therefore, V is equal to I into R is the Ohm's law. This much you have to write it for Ohm's law. This is for only Ohm's law. Then, how are ammeter and voltmeter are connected? You can see here, voltmeter is connected parallel to the circuit, and ammeter is connected in series. Ammeter is connected in series to measure the current. See, the next question is, why are these instruments have to be connected in electric circuit? To measure the, ammeter is connected to measure the current, and voltmeter is connected in parallel to measure the potential or voltage, you can say. For this reason they have to connect. So how do we have to connect the ammeter? Series. How you have to connect the voltmeter? Parallel. Ammeter, what it does? It measures the current. Voltmeter measures the potential difference. So this is the answer for that. Okay. Next. So next, for the same 9th question or another question, choice question. State Joule's law of heating. How is fuse connected in the circuit, and how does fuse work in a circuit? So what is Joule's law of heating? Let us consider a resistance is there. This is the resistance. In this resistance of resistance R, current is I, and this current is flowing through this resistance for a time interval of T. Then in this resistor there is a development of heat. Heat is developed, that is this heat. That heat is directly proportional to the square of the current flowing through the resistor, and that heat is directly proportional to the resistance of that resistor, then directly proportional to the time for which the current is allowed to pass through it. Combining all these three equations, we have this, that is H is equal to I square into R into T. That is a Joule's law of heating, which gives the relation between current, resistance and time. Okay guys, so this is the first question got over now. Now how fuse is connected in the circuit? The fuse is connected, see this diagram is there in your textbook, yes guys, yes. Then here you can see that fuse is connected here. Fuse is connected in series with a live wire. You have to write what? How fuse is connected in the circuit? It is connected in the series across the live wire. Which wire? Live wire. Here you have to connect the fuse. Okay guys. Next, what does fuse, how does fuse work in a circuit? See here, in live wire, suppose any high spike, high electric current occurs, at that time it breaks that, and our further appliances, home appliances, will be secured. If suppose it has a more capability to withstand, then high voltage will go to the our instrument appliances, they will get damaged. So any high voltage comes, like for example 13 ampere is a minimum current which can withstand by this fuse. Above 13 ampere it will break, so that we can save our appliances. That is how the fuse work. Then how do you trace a magnetic field lines around a bar magnet? Compass needle. Using compass needle, magnetic field lines do not intersect each other. Why? We have to explain. So we can see this diagram here. So first, to how you trace the magnetic field lines using the bar magnet, using needle compass box. So this is a bar magnet. This is bar magnet. And this is needle compass box. So first what we have to take a small compass and a bar magnet, place the magnet on a sheet, this magnet on a plain sheet of paper fixed and a drawing board using some adhesive materials. Then mark the boundary of the magnet. Second, you have to mark the boundary of the magnet. Then place the compass near the north pole of the magnet. See here, this is a compass. North pole of the compass is placed near the south. And we have to place a different place, so that finally we should take the south needle of the compass should be near to the north pole of the magnet. So like that you get one line, that is called as magnetic field lines, right? You can see those magnetic field lines here. See, yes. So this is the magnetic field lines what we get using the needle compass box. So this way we have to find out the magnetic field lines across the bar magnet. Next question, what are the causes for overload and short circuit in an electric circuit? What is the function of earth wire in the domestic wire? So this is a connection used in our every home. So here we have a earth wire which is represented by green wire. There is a one more live wire which is represented by red wire, and one more wire is there, that is neutral wire, right? So three wires will be there usually. Green is for earth wire, red is for live wire, and black is for neutral wire. So here earth wire is connected commonly to the long pin, and out of these two pin, one is connected to live wire, another wire is connected to neutral wire. This is what is the cause for overload, right? When the overload occurs, whenever live wire comes in contact with the neutral wire, suppose these two wire got touched each other, right? Then this will occurs a short circuit. Or overload, nothing but high voltage comes suddenly, then there may be possibility of these two wire will get contact. When they both will contact, there will be a overload and the circuit will break down, or short circuit will get, right? So this is cause for the overload. Then you can see that a fuse in a circuit prevents damage to the appliances, and the circuit due to overloading, the overloading can occur when live wire and the neutral wire come in direct contact. So this is the reason for overloading. So what is the reason for overloading, guys? Overloading can occur when the live wire and the neutral wire come into direct contact. Then in such situation, the current in the circuit abruptly increases. What happened during the short circuit? The current in the circuit abruptly increases. This is called short circuiting. This is called short circuiting. The use of the electrical fuse prevents the electric circuit and appliances from the possible damage by stopping the flow of unduly high electric current. So this is the importance of fuse. So what does fuse do? That fuse, if there is any high electric field or high current is there, it will break. Then it prevents the further damage of the appliances. That is the answer. Then next third question is there in that, what is the use of earthing, earth wire, right? The third is the earth wire that has green insulation, and this is connected to metallic body of deep inside the earth. It is buried inside the earth. Why? It is used to safety measure to ensure that any leakage of current, suppose any leakage of current occurs, it should not affect the, does not give any severe shock to the user. That's why the third wire is connected to the earth, right? Yes. Next 4-mark question. So here 4-mark question is, a given wire material having a length L, area of cross section A. So this is case 1. Length is L, area of cross section is A, and the resistance of the wire is 4 ohm. Next they are asking case 2, if the length becomes L by 2, that I will take length L dash, which is L by 2, and area A dash 2A, then what is the resistance? New resistance is R dash. Correct? Now you can check it out here. So what is the relation between resistance and length and area? That we know, resistance is directly proportional to length and inversely proportional to area. So here R dash can be calculated as R dash is equal to L by 2 divided by 2A. So here again 2 will get cancelled, L by A, which is again R. So there is no change in the resistance of the wire, it will remain same. This is your answer. Then next, in a electric circuit, the resistor R1, R2 and R3. So what is R1? R1 is 5 ohm. R2, what is R2 guys? 10 ohm. And R3 is 30 ohm. Right? Then next, it is connected to a battery of potential of 12 volt. Then calculate the total resistance of the circuit. Total resistance in parallel, they are connected in parallelly. So if you observe that, this is connected to a battery of 12 volt. This is 5 ohm, this is 10 ohm, and this is 30 ohm. Now what is the net resistance you need to calculate over here, right? So to parallelly, for parallel, you can write here, for parallel 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp is equal to so you can calculate this one. So taking the LCM as 30, okay, so by doing this, taking the common 30, so you will get 6 over here plus 3 and plus 1. So this will be equal to 1 by Rp. So it is 10 by 30. So it is 1 by 3. Correct? So your Rp become 0.333. So this is the resistance, which is 1 by Rp, sorry. 0.33 is 1 by Rp, then Rp is equal to, resistance in parallel is equal to So it is 3 ohm. Okay guys. So you'll get the answer as resistance as 3 ohm. Next, 5-mark question. So what is the refraction of light? The refractive index of diamond is 2.42. What is the meaning of this statement? So refraction of light, when light travels from one transparent medium to another transparent medium, it changes its direction. We know that when light travels from a rarer medium to denser, it will bend towards the normal. When it moves from denser to rarer, it will bend away from the normal. So that phenomena is called refraction of light. Then what is the meaning of refractive index? How much it will bend, how much extent it will bend, that is represented by some value for a given two pair of media. So here the first medium is air or vacuum, and the second medium is compulsory diamond, that is diamond, and which is fixed, that is that ratio is given by 2.42. that is the meaning of this one. And next question, what are the uses of concave mirror? Write the mirror formula. So here uses of concave mirror, the one is, it is usually used in torches, searchlights, vehicle headlights, dentists to see the teeth, and shaving mirror in the saloon shop, right? Then we have to write the mirror formula. So mirror formula is 1 by V plus 1 by U is equal to 1 by F, where V is image distance, U is object distance, and F is focal length. Yes guys, so this is a model question paper 2 explanation of physics part. Thank you for watching.